Alright, so today I want to talk about the rules of exponents. We're going to cover all three rules. I will not cover zero and negative exponents today. So all I'm going to cover is the product rule, quotient rule, and the power to a power. Okay, so starting off with this should not say multiplication rule. I made a mistake here. This should say product rule. So let's cross that out and let's put product rule. Okay, say product rule. Okay, good. All right, and so what the product rule states is that if you have a base, let's say a to the m power, and you multiply it to the same base or like base, so another a, and it could be the same exponent or a different number of exponents. This is the same thing as saying a to the m plus n. Okay, remember the m and the n and the a, it's just as a model. Okay, it doesn't have to be these letters, and it doesn't have to be an A. It just stands for representation of some number or some letter. Okay, so taking this into an actual problem, basically you want to have all of the like exponents together, or the like bases. Okay, so here I'm going to do in red, I'm going to do the x. So the x is going to be a base of x, and then you have an exponent of 3, so that's going to be to the raised to the power of 3. And then you have another exponent of 4, so we're just going to add the 4 to that. Okay, and then we have the other base, which is y, and that's going to be y to the second, so that's going to be a 2 there. And then y to the third, so that's going to be a plus 3. Okay, so according to this rule, we are allowed to do this. So x to the 3 plus 7, or I'm sorry, 3 plus 4 is going to give you 7. And then y to the 2 plus 3 is going to give you 5. Okay, so this would be our final answer here, and I'm going to explain to you in expanded form why it is that we add the exponents and we don't multiply the exponents. Okay, so what I'm going to do here is off to the right side here, I'm going to write out expanded form. Okay, so let me draw a line to have a barrier wall here. Okay, so this is going to be expanded form over here. Expanded form. In my opinion, this way is the most sure way, until you get really good at this, to solve the problem or simplify the problem correctly. Because everything's going to be written out in an expanded form, and you'll be able to easily identify how many x's what power to do and how many y's what power to do. Okay, so let me rewrite this expression here. I got x to the third, y to the second, and then x to the fourth, y to the third. Okay, and so when I do this in expanded form, basically I just want to write out what x to the third means. So if you recall, when you have exponents, anything raised to an exponent, all that means is that number, or whatever number that is, that means that the base is multiplied to itself that many times. So the base is x, so it's x times x times x in the first parentheses, and then you have two y's, so that's going to be times y times y, and then we can close that parentheses. All right, in the next parentheses we have x to the fourth, so that's going to be x times x times x times x, and then the y's, there's 3 of them, so that's times y times y times y a third time. Let me move over just a little bit. All right, there we go, and there we go. That's not a very good parentheses. There we go. Okay. All right, and so now all you do is you count up how many x's you have. So you can see here you got 1, 2, 3, 4, 5, 6, and 7. So that's going to be x to the 7th power. And then the y's, you're going to have 1, 2, 3, 4, 5. So that is going to be y to the 5th power. Okay, so now if you look at or compare our answers here, we have, this is our final answer. If you compare the answers, they are identical. So if you want to take the shortcut and do the rule, that is fine. Just remember that you have to remember that rule. Okay, good. So either way, the expanded form takes a little bit longer, but you still get the same answer. In my opinion, that's a more sure way until you get really used to exponents of how to get the correct answer. Okay, moving on to quotient rule. All right, quotient rule. So we're going to use the same base of a to the m power, and this time, since it's a quotient rule, that means an answer to a division problem, so we are going to be dividing, or in other words have a fraction bar, and then we have a to the n power. Okay, and so this the same thing here. We're going to just write some model. Okay, the a, the m, and the n just stand for representations of some number or some letter. Okay, all right, so if we did the product rule and we added exponents, we're going to do the opposite when we do the quotient rule, since division is opposite of multiplication, and we are going to subtract exponents. So this is the same thing as a to the m minus n. And what I'm going to do here is I'm going to put a bullet point over to the right here, a little asterisk, and I'm just going to explain here real quick. When you subtract, you want to do the top exponent minus the bottom. So we want to go top exponent minus, wow, that is really bad handwriting, minus the bottom. Okay, we don't want to get into subtracting the bottom from the top. Let me erase this. I don't like this minus. Okay, there we go. So that is minus. Okay, cool. All right, so there we go. There's our model there. A to the m over a to the n is the same thing as a to the m minus n. Top exponent minus the bottom. Okay, so let's put this into a problem. All right, so we want to simplify this expression. We have a and we have b. Doesn't matter what a and b are, but we can simplify it. Okay, these are just variables. So doing the shortcut way, we are going to use a. So we have a base of a, and it's going to be sorry about that. I think I accidentally hit a button. Okay, so we're going to rewrite this. A to the third power, b to the fourth, over a to the second, b to the second. Okay, so how do you solve this in expanded form? Okay, so this is the same thing as basically rewriting the top. So on the a's, I'm going to write 3 a's on the top. A, and remember, if there's a variable right next to another variable, that's just multiplying. So I don't need to put the multiplication sign in between. All right, and then the b's, I have 4 of them on top, so that's b, b, and b. Okay, then you want to draw your fraction bar. And on the bottom, we're going to expand that as well. We have a to the second, so that is just a times a, just like that. And then the b's, we have 2 b's as well, so that's b times b. All right, and so now all we do is if you have any number or any letter divided by itself, it's just going to be 1. So anytime you have a letter over the same letter, you can just cancel those out. So we're going to put a slash to the first a's and also to the second a's. Okay, so notice how we don't have any more a's to cancel out. So let's go on to the b's. Well, we have a b on the top and a b on the bottom, and we have one more, b on the top, b on the bottom. Okay, so now you don't have anything left to cancel out. So now this is the same thing as, so this is equal. Okay, how many a's do we have on the top? We have just 1 a, so that's going to be a to the first. And then how many b's do we have on the top? Well, that's going to be b to the second. B to the second. There we go. Okay, and then you can put a fraction bar if you want, but it's really not necessary on this problem because since we don't have anything left on the bottom, all the a's and the b's canceled out, we just have a 1. And we know anything divided by 1 is itself. So this is the same thing as saying a to the first and b to the second. And once again, you can actually erase this 1 if you want to. You don't need to put that there. Okay, so there's our answer. And so now let's compare. On the left side, we did the shortcut, just subtracted the exponents. On the right side, we did expanded form. And we got the same answer. Okay, so it doesn't matter which method you use, but I encourage you to choose one of these methods. If you like doing the shortcut, that's great. Just make sure that you have to remember there's going to be 3 different rules you have to remember. All right, and then if the expanded form, there's not much you have to remember except what does an exponent mean, and it's really easy to write out the expanded form. It just takes a little longer. Okay, last rule to learn here is power to a power. And all this means is you have, let's say, a to the m. I'm going to stay consistent with the letters here, in parentheses, and then that is raised to the n power. So the reason we have a power to power, because we have an exponent of m raised to another power of n, or an exponent of n. All right, so this one, I want you guys to think about this as like distributive property. This n distributes to the exponent inside. Okay, so this is going to be a to the m. Now we're going to get into multiplication times n, just like that. Okay, so that is how you do it the quick way, or the shortcut way, is by just remembering this power to a power. Okay, so going into a problem here. To simplify this, basically what you want to do is you want to take this 3 on the outside, you want to distribute it to the 3 on the inside, and also to the 2 on the inside. It does have to distribute to all of the exponents on the inside. So how many bases do I have on the inside? Well, I have a g and I have an h. Those are bases. Okay, so that means that I need to distribute 2 times. Okay, if you have 4 bases, you distribute 4 times, and so forth. Okay, so the 3 distributes to the 3 on the inside, so now I'm left with, let's go red, so we'll go g to the power of 3, and then times that one on the outside, so that's times 3. Okay, and then we have h to the power of 2, right? We have a power of 2, and then that is multiplied to the exponent of 3 on the outside. Okay, so when we simplify this, it is going to be g to the 3 times 3, which is 9, and then we have h to the 2 times 3, which is 6. Okay, so if you remember all the rules, this doesn't take you much time at all to be able to simplify fractions. But if you don't remember them, there's no shame in that. You could just do expanded form. It does take longer, but as long as we arrive at the same answer, it does not matter how we get there. Okay, so now I'm going to do expanded form. Okay, so I just went over power to a power, so now let's go over expanded form. Okay, expanded form. All right, very good. So let me rewrite this expression so I don't have to keep zooming back and forth. We have g to the 3rd power, h to the 2nd, all in parentheses, and then raised to the 3rd power. Okay, so think about, since we have an exponent of 3 on the outside of the parentheses, that means we basically just rewrite the parentheses 3 separate times. Okay, so in the first parentheses, we're going to have g to the 3rd, h to the 2nd, and I'm going to get rid of that exponent on the outside, and I'm just going to write this out on the form of what I know exponents is. So that's g to the 3rd, h to the 2nd. Let me scoot over, run out of room here. And then one more, g to the 3rd, h to the 2nd. All right, perfect. So notice how I just wrote it on expanded form. That is the same thing as saying g to the 3rd, h to the 2nd, all raised to the 3rd power. Okay, and then now if you only remember product rule, now it's really easy. You just add all the exponents together. So if you think about it, if you just get rid of power to power, then all you have to remember is product and quotient rule. Okay, but I am going to finish writing this out in expanded form. Okay, so the first parentheses, we have g to the 3rd, so that's g times g times g. And then there is 2 h's, so that's h times h. And you can see that all the parentheses are actually going to be the same thing. So that's g times g times g, then h times h. And then in the last parentheses, we have the same thing, g times g times g, and then h times h. Okay, perfect. And so now, if you remember the product rule up above, if you don't remember the rule, then this is the expanded form. And all we do is we add up all of the g's. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. So that number 9 is going to be your exponent. G to the 9th power. And then now your h's. 1, 2, 3, 4, 5, and 6. So that is h to the 6th power. All right, and that is going to be your final answer. Okay, so let's compare answers. Very good. We got the same answer doing the shortcut way and doing the expanded form way. Okay, so once again, I do encourage you just to pick one way. Either pick, I want to do the shortcut or I want to do the expanded way. And it doesn't matter which way you choose, the expanded just takes a little bit longer. Thank you.